Hello everyone. Today we're going to do Mohs hardness scratch test. Now, this is a way to kind of identify a mineral or aid in that process, but you want to do it several times and take an average. But the average isn't as simple as just like adding a bunch of this stuff up. All right, but I'm going to explain to you a little bit here, give you a little background. First of all, we're going to do this rock. Now, I do have a microscope that the long edge and a digital one, when I'm zoomed out, the long edge of this screen is 7 millimeters. When I zoom in, it's 2 millimeters. So I can tell by looking at this thing does have a tiny bit of quartz in it. I do know what this is, by the way. But so that's going to probably up our value a tiny bit, okay? So keep that in mind when we do this, but I want to show you something first. I'm going to use a Mohs hardness test kit here. Now, the thing in this corner is a magnet. These things are very expensive. They're also the same as a concrete hardness test kit, except doesn't come with the streak plate and the magnet and that stuff, but just about anywhere. Except on the red, it kind of pushes, it did it before. You can tell when you go to do it, it doesn't want to stay. It kind of moves towards the gray stuff. The red is not jasper. It's actually a coarser silt. So in this case, and like I said, this, you can see the shininess. The grains are mostly hematite and magnetite. Magnetite is one of, two minerals that are naturally magnetic. And by the fact that that was sticking on and holding tells me there's a significant amount here. Now, when you look at these here, these tools, we're going to cover these real quick, especially the lower end ones. And there is a sharpening tool included. This is 2. This is plastic. I don't use this unless I know I've got talc or something like a clay or something just as easily soft, because that's a plastic tip and I don't want to break it. You can buy replacement tips and you would just unscrew this. You can see there's a thread there. You need a pair of pliers to do this, or wrench, I forget the size. And you just undo it, replace it. This is copper. That's their 3. So you can use that. The rest are metals. I forget what's what. But you may be like, well, there's only 4 here. There's 1 through 10 on the Mohs hardness. Well, these are actually 2 on each side. You saw that. So I actually have 8. But I still don't have a 1 and a 10. Why? Well, because 1 is so soft, you really can't make a tool out of it. If you're going to dig deep into it with the plastic tip on a number 2, you know it's really soft, okay? 10, diamond, can't really make a tip. Diamond is about as hard as it gets. There's 1 or 2 minerals that might be a 10 or close to it, but diamond is the actual 10. It's the reference mineral. So you can't really have those 2. No metals at 10, okay? So you got these, and this is what you got to work with. So what do you do here? How do you do this? Well, I'm going to show you. We're going to first take this, and when you do this, your pressure you want to apply, and I'll go over this before I do it, is I hold it like this, okay? Because it controls me, it keeps me from going too deep. Like when you're writing, I'm left-handed, by the way, and you start pressing really hard, and you're trying to, and it happens, that's too hard. But you don't want to be doing this either. That's not going to do anything, okay? So you hold it like this and you apply pressure, and each time you do this, you have to be consistent, okay? And I find this way holding it's the best. Make sure you're not going to stab yourself, all right? And we're going to do the flat part here, all right? And the reason why I'm doing this is because I know hematite and magnetite are about the same hardness. They vary a little. What is it? Hematite's between 5 and 6, so the average of 5.5. Magnetite's 5.5 to 6, which is 5.75. And those 0.75s, we actually just round to quarter increments. It's actually 5 3/4 would be the exact number. We just write it like that because it's easier. Now, of course, when you do all this, you might get a different thing. But anyway, this here, when I do this like with the 2, here, we'll just do the 2. Apply the pressure. And you can see it did leave a mark, but when I do that, it's gone. You got to remember, when you do this, you should do that. And you need to know if your tool's scratching the rock, your rock's scratching the tool, okay? So that would be a 0, no scratch, all right? And we're just gonna fill it in here. I said I don't like using the plastic tool. Okay, so there's no scratch. 0.5 is minor. What does that mean? Well, let's do our 3. We're gonna do the same thing. You can see the copper streak, but what happened? Did our tool streak the rock or vice versa? There's really nothing there at the 3. All right, so we're just going to say 0. Okay. Now, let's do the 4. All right. I forget what metal this is. You should do it in the same area, but not in the exact same spot. And if you're doing an individual mineral, you want to do the same mineral face, okay? I don't know if you can see it, but that definitely scratched it. Barely, but it did. So we're gonna have a 0. Because, the hardness part, honestly, this makes sense too, because as you go harder, the deeper the scratch is going to be. Minor is when you can tell it definitely scratched, the tool scratched the mineral, or in this case rock, but it's 2 minerals and I know what they are. It's obviously going to do it at different depths with the same amount of pressure. Just like if I do a 9, it's going to gouge it, okay? But you stop when you get to 2. You don't need to go further than that. So here's our 5. Holding it like this. Same amount of pressure. You're not going to see it very well. That's probably a 1. And these are judgment calls. 1, this should be somewhat close to what your actual hardness is. Okay? But we're trying to refine it. And this can help us if we're debating 2 minerals, like which is dominant, hematite or magnetite, even though we may know what they are. The 6, you need to get another tool. Be careful not to stab yourself. I do it all the time. And they don't have to go 0.5 to 1 to 1.5 to 2. It can go from 0 to 1 or from 0 to 1.5. It depends on the hardness. Okay, now we have our 6. 1 or 1.5. Let's say 1.5. Okay, because it's not that deep. Now deep, I get to 7. I can tell. And then if you have any doubts, take your hand lens and look. The deep should form a discernible groove that is not going to get rubbed out. So should this. This you should be able to rub out with sandpaper on most things. This you could probably rub out if you try hard enough with a cloth. If you can rub it out with your finger, obviously it's 0. I'm just going to take these off so I stop putting them back in my face. Try not to stab myself in the eye. An 8. Oop, sorry. You can probably see my 8s. Those are deep scratches. That was my 7. It's not quite as deep as these. Now, I don't need to go to a 9, okay? I'm good. Now, when you do this, you want to take an average, a mean average of these numbers, okay? We'll just say mean. No, I don't want to do MA because that's millions. Average, mean, okay? So you're going to add all these up. You're going to do 0.5 plus 1 plus, these are 3 plus 2 equals 5, 6.5. Okay, it just happens to be this way. Sometimes this number gets really high. Now, we don't do these because we don't need to, okay? We don't do zeros. Now, when I do this, it should fall somewhere in here. If you do this and you get like a 2.2 or a 3, you screwed up, okay? It should be between these numbers, okay? 0.5 and 2. So I divide this by 1, 2, 3, 4, 5, by 5. And I cannot do that in my head. So I get 6.5 divided by 5. I know it's 1 point something. 1.3 equals 1.3. Now what do we do with that? Well, is that our hardness? No, of course not. All right. But where does this fall? 1.3, well, you have 1.5 here and here. So it falls in here somewhere, is 1.3, because it falls between here and here. Now, between these two, okay, this is a close to, 1 1/4, something like that. It's close to 1.25, all right? So 1.25 right here, 2.5 is halfway between these two, right? So halfway between this is 5.5. This is my hardness. Magnetite has an average hardness equal to 5.75. Hematite is closer to 5.5. Average, but these are ranges, okay? So this would be more typical of hematite. And when I put that magnet on there, it stuck. It wasn't really hard, but it wasn't weak. It stayed on there no matter which way I turned it. So it makes sense that it has a lot of magnetite, but also a lot of hematite, okay? And the quartz didn't mess with this much because there really wasn't a lot, and I tried to streak it on a flat surface. When you have a nice fracture like that, if any quartz you have is going to go across grades. This is metamorphic a little bit. There is some green chloride in here. This is banded iron. Now, you would do other tests and other gauges, like maybe density and stuff like that, to get a better ratio of how much magnetite to hematite. But the fact we have this, and we know our magnet sticks, which means out of those metallic oxides, those iron oxides we have, those iron oxides, since we have a hardness of this, and this does take practice, okay? It really does. A 5.5, we have more hematite, but that magnet's stuck. So if we had to just take a percentage, if I didn't have a microscope and just roughly did it, and with the microscope, you could definitely tell the two, they're not in the same crystal system, and this actually has decent crystals. Okay, they're just small. You just magnify them, okay? We would get about 60% hematite, and this is specular hematite. This is that raw ore stuff you want. We get about 60% hematite, and we get about 40% equal to magnetite, plus or minus 5. This is just a rough estimate based on this. Those are not the actual numbers. I think the hematite was actually closer to 70 a little bit, and this was closer, because there's something else in here too. There's goethite, okay? But it's such a small amount. And this, I think, was more like 35-ish, somewhere in that. It wasn't always 30, but between 30 and 35, somewhere in there. I don't remember off the top of my head. But you can do this for just about any mineral. And like I said, this is a rock. You should really do this just for minerals unless you're really good at this. And you have to be able to know where to scratch, But I do like this piece a lot. I think it's pretty cool. And anyway, like I said, these are basically concrete scratch tests, but those will just come with these. You won't have all this other stuff. I will link my rock test kit. The intermediate rock test kit, that's going to have its own box, but has not come out yet. I think I gotta wait about 10 more days for those to come. I don't know if I will put these in here. I have to see if I can find something cheaper than just a complete set, maybe 101. I don't know. If not, they'll be in the advanced kit. So anyway, I think that's it. If you have any questions or comments, please leave them below, and I hope you learned something.